Hey guys, welcome back to my YouTube channel. Don't forget to like and subscribe and comment down below what you think of these videos. Just kidding. We are back with 2.5, comparing and ordering real numbers. So here's what we're going to look at. Problems like this. If you read this, the dimensions of a baseball field are very specific. For example, the distance from home plate to the outfield line is required to be at least 200 feet. The distance from home plate to second base is the square root of 7,200 feet. How do you compare two real numbers written in different notations? Well, that is what we are going to look at today. We can compare them by writing them in the same form. So one way to write them in the same form is to write them all in decimals so that we can compare them to each other. So if we want to compare 18/5, pi, and square root of 11. These are three numbers in very different forms. The way we are going to do that is to first write them in decimal notation. So you can follow along on page 111. There are some blanks for you to fill in for this one. And so 18/5 as a decimal is about 3.6, or is 3.6. Pi is approximately, remember we used this symbol yesterday, approximately 3.14, and the square root of 11 is approximately 3.32. So then once they're in decimal form, we can compare them. 3.14 is less than 3.32 is less than 3.6, and we could put them back in their original form, pi, square root of 11, and 18/5. We can also graph these numbers then on a number line. 3.14, pi is about here, square root of 11 is about here, and 18/5 would be right here. So we can see on the number line the order as well. That pi is the smallest, then square root of 11, then 18/5. So this is how we would order our numbers. So you'll see problems like this, and we are going to figure out which symbol, less than, greater than, or equal to, would complete the statement, square root of 8, blank, 2 2/3. So the first thing we have to do is find the decimal expansion of each number. And again, you can fill in these blanks on page 112. So the page number is listed up here. So the square root of 8 is approximately, let's see if this one will work best. And you can use a calculator to do this, 2.8. And 2 2/3, we've done this before. 2 2/3, we can just figure out what 2/3 is of the decimal, which is 0.6 repeating. And so now that we've figured out what each of these numbers is, we can compare, since 2.8 is greater than 2.6, square root of 8 is greater than 2 2/3. And then we are going to graph each of these on a number line. So 2 2/3 would be approximately here. 2.8 square root of 8 would be right here. And again, you could see that on a number line, numbers to the left are smaller than numbers to the right. So here's another example if we want to compare these. Okay, I got interrupted, but let me finish here. So the first thing we have to do is take each of these numbers and write them as a decimal. So pi squared, I'm going to use 3.14 as an approximation for pi. Pi squared is approximately equal to 9.86. Again, you can use your calculators to help you with these calculations. And 9 1/4 is 9.25. So seeing that 9.25 is less than 9.86, we can say that pi squared is greater than 9 1/4. So again, to compare them, we're going to find the decimal value of each and use that to compare them. And then again, we can graph these on a number line. So if we have 9.2, 9.3, 9.4, 9.5, 9.5, 9.6, 9.7, oops, 9.8, 9.9, then 9.25 would be about right here, 9.86 would be about right here. So again, you can see from the number line which one is smaller as well. Smaller numbers on the left, larger numbers are on the right. So now you guys do this, pause, and do the check problem on page 113. And in the margins, you can write this down just so I can see right next to on page 113, somewhere in the margins, just write. That'd be great. And so now that you've paused it and tried the problem, the answer that makes that statement true, square root of 25 over 2 is actually equal to 6.25. So as a decimal, those are the same values. So if you were graphing them, the correct graph would be graph B. So you can check your answer there. All right, so we're going to compare numbers again, but this time our numbers are negative, and it's a little tricky with negative numbers because it's actually backwards. So the quote-unquote bigger negative number is actually smaller. So for instance, -7 is actually smaller than -6 because it's further to the left on the number line. It's further away from 0. So even though 7 is bigger than 6, -7 is smaller than -6. But we're going to do the exact same thing. So even if we want to compare negative square root of 6 to negative pi over 2, we are going to find the decimal approximation of each number. So the decimal approximation of negative square root of 6 is negative 2.4. And then negative pi over 2 is negative 1.57. So again, very easy to see once we have the decimals, because they're not that close to each other. Negative 2.4 is less than negative 1.57. Excuse me, greater than, sorry. Oh my goodness. It is so very late at night. Less than, I don't know what I'm thinking. Yes, bigger numbers, negative, are smaller. I was right the first time. Sorry, guys. So negative 2.4 is less than negative 1.57. So we can say up here that this is less than negative pi over 2. And again, we can also graph these on a number line. So negative 2.4, you can see is right here. Negative 1.57 would be about right here. Ooh, the other one disappeared. Oh, why do these keep disappearing on me? Interesting. So we can see that negative 2.4 is smaller than negative 1.57 because it's further to the left on the number line. So same thing here. If I want to compare this, we're just going to find the decimal values of each. Or actually, these are both square roots, so we don't even have to change them to decimals because they are in the same form. So what would be bigger, square root of 2 or square root of 3? If they were positive, square root of 3 would be bigger, but since they're negative, square root of 2 is actually bigger than square root of 3. And the square root of 2, the negative square root of 2 is negative 1.4, and the square root of 3 is negative 1.7. So negative 1.4 is here, negative 1.7 is here, so you can see that negative square root of 2 is bigger than negative square root of 3. So there's another one for you to try on page 115, and in the margins on page 115, write the word homework. And I'm going to look for that word when I check in your homework for this video. Okay guys, that's the end of this video. Make sure to like and subscribe and look for my new video posting tomorrow. Later.